Thank you so much. Okay, yeah, thank you. So I'm getting louder and louder anyway over the next 45 minutes. Yeah, so thank you so much. Engage, Tabor Communication and the teams to get me here to this great event the first time. We are wonderfully pampered, and it's almost easy to give a talk in such a friendly and relaxed environment. So, okay. I already introduced myself just a couple of minutes ago here with the other nice guys there over there. So, okay. I'm really astonished that during this conference there is so much talk about cloud. I mean, even last year I haven't seen that. Increasing interest, and there are, okay, when I think about it, a couple of very good reasons that this is in a sudden the case, and I will get to that in my talk. So let me try to learn this technology here. Okay. Okay, so in the meantime, you might have had time to read this very nice quote from Fegan. She is the new general manager, HPC Software and Cloud in Intel, directly reporting to Raj Hazra. And Intel, since now 3 years, they accompany us already for a long time. We are very grateful for their support. And I mean, and we are working together now very close on next generation technologies and so on in this space to especially make the access to HPC resources, and in our case, the HPC cloud resources, easier, very easy, basically seamless and transparent. So that is what comes, what is already on the table, but we now implement it kind of at large. So let me try that one. Yes. So I grabbed a quote from you guys because I loved it. I mean, it would be boring to not working on something cool, right? And it is, obviously it is cool. You will see that. I mean, I put more meat to that one. Already my first question is not really correct, but that is the question which we hear the most. So why HPC cloud? It should really read, why HPC and cloud? HPC cloud does not replace what you have. Not on your desk, not in your server, around the corner. So it is a complement, at least in this transition phase, which might take 5 years or so. So our motto is, don't change your running system. Just keep it up and running. Replace it, whatever you do in-house, because you have most of the trust you have. I mean, it's in this running system. The cloud is still something you are learning, you are trying to explore and testing, but there is not full confidence in it yet. So far for now, we tend to like to say HPC and cloud. So yeah, okay. So why now? Right, so let's really start that. I mean, we are all easily excitable, so excited about this one. It's cool, but there's more to it. I mean, if it were only cool, okay. But it is really better, faster, cheaper. Better, I'm talking about quality, for example. The engineer is mostly interested in creating, designing, developing better products. Better meaning higher quality, better than the competition, and you can only do that by experimenting, which parameters are the best ones for material, for geometry modifications, and so on. The more runs you can do, the more jobs you can throw at your system, the better for you. You get more results. You could do stochastics over the results and then find the best suited material for your plane, for your cars, etc., etc. So this is the better thing. With cloud, you add more power to your existing environment at your fingertip, and we'll get to that faster. Okay, this could be about time to market, right? And you all know what that means, so I don't have to go deep into that one. So there are these dimensions. You could be faster, or in the same time you could do more, right? You could do, okay, we will get some examples. cheap. Oh, I forgot cheaper. So let me look at cheaper. And at the end of the day, for many engineers who just have a workstation on their desk, this one is the cloud is really cheaper because. So what we recommend is, in almost all situations, is a hybrid approach. So if you have a workstation, bursting out into a cloud might be better because if you have kind of deadlines, if you have peak demands, etc. So there is a cost analysis on our website where we clearly calculate even the crossover. So when is cloud better and when is buying a server better for you? So there is, it has to do with load. So how much load on average can you bring to your in-house server? If this load is high, then it is cheaper to run your in-house server as is. But if your load is below, on average, like something like 60–70%, then you really rather consider to go into the cloud for everything which is over that. So one very important thing, though, better, faster, cheaper is nice, all these benefits. But the biggest problem our community faces towards moving or towards our ambitious goal to move towards democratization, it is really about that one. For the average engineer who is really a great designer and developer of a product, it is still very difficult to access and use a supercomputer, right? And you will see that we are trying hard to make this access and use absolutely, I wouldn't say trivial, but very similar, almost identical to the access to your workstation, right? So you go through your workstation and you don't really feel in a sudden that you are in the cloud. So I will get back to that one. So this is a little bit a summary of some deep dive in a few minutes. So why now, this is a discussion here as well. So why do we believe that it's coming soon? So what are the signs of the market and of our community that we can say, okay, within the next 2 years, it is almost commonplace. So despite the numbers which IDC shows every year, which you see, this is a growth of 6% on the revenue side and the growth of units 4% just on the unit side. This is not really encouraging, doesn't really show that this is democratization. I mean, we hope to see these numbers explode. But IDC is, when they did that last year, they didn't really look at these market signs. And I have to confess also that this is just more a gut feeling. You know, you cannot really prove that there is an explosion of the market or a drastic growth of the market within the next 2 years. But I will take you to that. So there are a couple of very good reasons why cloud, also in HPC, also in computer-aided engineering, in computational biology, pharma, oil and gas. And you know, in some areas it's already kind of there's a lot of movement going on over there. But you know, we heard some discussions about HPC will move into IT, into the IT department, if it's not already there. And in the IT department, there's already a lot of cloud things going on, you know, with the enterprise applications. And in IT, CIO, COO, kind of representatives of a company, they will ask you, when you as an R&D director, I want a new machine. So they will clearly ask you today, so and what about the cloud? So you have to have a good story and financially solid ground that you still justify to buy a newer and bigger system. Maybe you can agree to a compromise saying, okay, I want a similar size, want to fill it up to 90%, and everything else, yes, I burst into the cloud. And I have an intelligent scheduler who can decide which application sticks inside and which can easily go over into the cloud. There are these workload managers out there today which have this intelligent capability. So engineers growing awareness about the benefits. I mean, we have written about 120 articles about our use cases, about the benefits, and also about the challenges, etc., and published them everywhere in HPC Wire. Tom was the first one who published our very first article 3 years ago, which we together, basically almost together, wrote in Cetraro at one of these HPC meetings, sitting in the morning in a beautiful Calabrian environment and getting very creative. So engineers, yes, they get aware more and more because of all the noise the vendors are doing, their providers are doing, and I will get back to that. It's a lot of noise. And finally, engineers are already working, sitting, doing things in the cloud, very often without recognizing it, with buying things, flying over, getting tickets, and so on. So there's a nice word when you type in that. Work imitates life, very often, right? So what is in life getting more and more common? People try, bring your own stuff kind of thing, BYO, X, whatever this is today. So this is from CDW's State of the Cloud report, etc. So the large guys expect suppliers to do best, better, faster, cheaper as well. So the suppliers, like the big guys, the Boeings, GEs, etc., they have huge supply chains, and they expect more and more quality, just in time, etc. So, however, very often these smaller companies cannot afford to buy the big supercomputer. There are compromises so that these guys are almost living at the big guys' environment and doing their stuff over there, at least with final testing, integration into the bigger airplane or whatever they are working on. So there are more, and here they are. These are really, more HPC specific, and they are more impactful. So this is almost dramatic that finally ANSYS got out last week in HPC Wire announcing their enterprise cloud. It took them 3 years to get there, right? It is for a big, long living already. They are something like 40 years old, and they got so many bloody noses legally over time that they are now very cautious about getting their stuff in the cloud and getting their customers using their cloud stuff. They're sitting on Amazon, AWS. So the other one, obviously, a big push into HPC is big data, right? We all know big data without analytics, it's still big data, right? So that will be, and is already ongoing, a big move. Then we have the makers. We have 30 million makers coming into HPC over the next 5 years. So currently we have 20 million. We have 20 million engineers and scientists where we know really they do simulations on their desktop, right? They have all their little HPC machine over there, right? And now we want to take them easily, seamlessly into the cloud. And you will see how we try to do that. So makers, these numbers were high. Okay, don't take me too serious. I got this number from our biggest sponsor. So they talk about this internally a lot. That's a big thing. If you want to do some little nice 3D printing thing and you want to give it to someone else, you better simulate it before you give it away. Otherwise you get sued, you get whatever. You lose friends, which is worse. So MOOC stands for this massive open courses, the massive open online. Thank you. Yeah, online, and that's the trick. It's online, right? And certainly, there are already online courses about OpenFOAM and other CFD software, for example, right? We have some stores in our marketplace now for companies who do training. So they take for their trainees. In a sudden, they travel without equipment. So it's not really online. So what they do is, in a sudden, no computers anymore, nothing. The attendees bring their laptop. And with their laptop, they access an OpenFOAM container on AWS, Azure, Nephoscale, and so on. and whenever they want, at their fingertip. So we open an account that is whoosh, and then during the course, they open up, they are sitting in the cloud. They have the biggest system they can ever imagine within, seconds. I will show that. And finally, so our digital natives, they will laugh at us. How conservative you guys are. I mean, I got born with some antenna and as you see. So for those in the last row, so our settings seem to be different. Yeah, you're equipped with a Wi-Fi antenna and I'm stuck with a USB port. So that's how these guys are communicating, right? Yeah, digital natives. I mean, it's they change our education. They will, because they force us to. So, okay, now getting more serious. There are also some technology things going on, and I mean, we already know this is possible. So we have, let me just check that. Yeah, battery is low. Okay, so this is already available today. So there are a few design and computer-aided design, computer-aided engineering companies which didn't use any licensing, shipping software around. They really started on a browser-based application, which, among others, you access through your iPhone or any other smartphone. Then, seamless portability and deployment via containers. And our take is really that will finally change the whole way people access and use cloud resources. But the nice thing, what we found out, when we talk to people about that, they say, I want to have that in my private cloud as well. Because I want to have a library of all these beautiful applications. Now I'm working on ANSYS R16, but I still have some very important things which I need to keep on R14. So it's in a library now. At your fingertip, you have it, and within seconds, you can deploy it. It is, when you want to freeze or hibernate things, I mean, you just put it over there. Don't touch it. You don't have to touch it if you need it, but however, it's there. It changes the way we deploy software at one point in time. But the base containers, they, like Docker is made from microservices, basically, and it is beautiful. I mean, because it's stackable, it's portable, and a lot of other good things. But what you already see here, so you see things like Amazon, ESI Group, PEMCrash, and these things. And so you see CPU 24/7, so you see hardware providers, software providers, HP over there, Bull over there, Autodesk. So everything basically can use these containers. So what we started 2 years ago is we took the Docker containers through 5 engineers on the project, and within a year they basically added about 15 heavy additional capabilities, tools into that: remote visualization, virtual network on the fly, your private PVN, PVN on the fly, and monitoring, reporting, things such that you get full control over what happens with your stuff in the cloud. Losing control is one of the big concerns of the engineers, and it relates to the trust issue in these new technologies. So you want to get them as much control as possible, even if it's remote, right? And this is easily possible with that one. We are already, yeah. So the market is, as I said, 20 million, and it's over there. So unfortunately, our market is very scattered. So we have about 16 verticals, according to IDC. They are all talking a different language. For sales guys, that's why we have, account people, or those who cover one of these areas. But they have all one thing in common. They need computing, right? And that's where an online platform like UberCloud comes in. Everybody wants the same thing. So they find, even already today, they find their right store. So I will just get you that one. So the market, so the future is, especially now, what we are still missing. I mean, in the very early days, HPC was something for the labs, right, and governments, and it was growing and growing. You know, more and more users came into play, but still there are a lot of smaller and smaller and smaller companies, and even you know, consultants not being able to get access to these resources. So there is one well-known thing. So when you have 140 customers, right? So the pattern is usually like that. Yeah. So there are a few ones which bring in a lot of revenue, and then there are a lot of others who are bringing in small revenue. But when you really look at you know, the first 20, the revenue of the other 120 is very similar in total. So you would miss, if you only concentrate on the big guys, you would miss half of your revenue, right? And there is an interesting other fact. So it's about, you know, the long tail, obviously. Here you see the enterprise customers, and here you see all the small, medium businesses. So many companies simply neglect this long tail, which is about 50% of their potential revenue, because it's difficult to get to them, right? With my 5 or 50 salespeople, I cannot really go to every representative of this long tail. So there is only one solution, right? And Amazon basically discovered that already something like 15 years ago or so. So, and there is another real benefit. The top guys, they will squeeze you. They will negotiate, and it's not really scalable, so you have to invest, etc. The small guys, I mean, you can package something, and when the benefits are high enough, they don't ask really for a price, because price is not their major concern. Their concern is quality, right, and time, yeah, and competitiveness. Okay, so the long tail will give you additional profit, yeah, because I mean, I know. I mean, on some of our packaged solutions, we put 40% on it, right? So for very good reasons, because we are investing like crazy now, right? We're still private. So how did we get there? That's the question. That's basically also the kind of the title, which changed several times. My name is still TBD, so that's my short name now. So discover, try, buy. It's very natural, so it's nothing surprise. I want to run through this, but one thing is important. I mean, we have the engineers, scientists, okay, the software vendors, and it says instrumental. I mean, when you want to approach this long tail, and long tail meaning, I mean, it starts with companies with 5,000 employees, right? They are still medium-sized businesses, and then goes down to the one-man, one-woman show, right? So software vendors, they are instrumental because they are closest to the end user. The end user is almost married or locked, because when you have invested 5 years to learn everything about Fluent with 220 knobs, yeah, then you won't give it up easily, other than they would, which they don't, they would do a very bad job. So that's the key which we use to get closer to the end users. So I'm going to almost any of these end user conferences around the world to meet them and to talk to them and to make them using our learning environment first. Learning, then exploring, etc. So, okay, then backward. Okay, 3 years ago, so you have seen the other guy on the first slide is Burak Yenir, my very dear partner, who approached me with a good question. Why the hell, why are you guys in HPC so slowly adopting cloud while we in enterprise, so he was vice president of cloud computing at Fiserv, financial services company, big one. So while we in enterprise computing are adopting the cloud already, I mean, for already a few years. And so that was a good discussion, and we finally found out we don't know anything about it. We don't know the real reasons. Everybody's talking about that. So we decided to do experiments. Okay, so I get back to that. So the experiments are to explore the end-to-end process using cloud computing resources as a service on demand at your fingertip. So that's a little nice. But the most important thing about these experiments is we want to learn how to resolve these roadblocks. We want to learn the roadblocks, the real ones, in every single case. In the first 2 years, 50% of the experiments failed. They couldn't get the license. They couldn't really talk to the software provider. The software provider didn't listen. The data, they couldn't get the data back, so they shipped it over FedEx, and many more things. They took the proposal to the management. Management said, no, security, and all these kind of things. Yeah. So 50% was very important for us to learn, especially why these guys failed. For these efforts, and we are very grateful to Tabor Communication to kick it off quite a few years ago. So they made us, their readers made us the best use of HPC in the cloud in 2013. So we catch 2 of them. Not that many like SGI have. Where's Tony? Oh, yeah. I was really jealous, envious when I saw that. But we got 2 of them. And recently, so today we have 172 experiments. And interesting enough, there was 1 experiment in it which was about oil and gas. And Gartner caught that. And funny enough, so after 1 interview or so and a little write-up, they made us a Gartner 2015 cool vendor. And you don't pay for it, right? So that's the amazing thing. You're really surprised, right? In oil and gas. Yeah. So we had 1 experiment from 172. 172, there were about 10 bioinformatics, about 10 big data, and the rest was CAE, computer-aided engineering. Because, we talk their language. So I'm an engineer myself, right? So I know that space quite well. So end user, software vendor, team expert, resource provider, ready to go. 172 teams. We throw them on Basecamp, so they collaborated in a closed environment. And then after 2-3 months, they wrote a case study. Those who succeeded, right? So one of the teams is 142, Autodesk Application Simulation 360, and end user Mark Lobo. Software and so on. So this is also running on AWS for now. So very nice results, obviously, and simulation here, etc., etc. What is interesting is what local versus solution. Okay, so 1 scenario, 1 hour on a dedicated workstation. 3 to 4 hours running modular in parallel. Okay, so CloudSolve is 10 scenarios in 2 to 3 hours. Let me go to, okay, so there is an order of magnitude in saving. So they did 800 hours compressed into 1 day. 800 hours, if you take every run and put it one after the other, yeah, with no crash, no, everything functions well then. So it is an order of magnitude. So 800 hours versus basically 24 hours in the cloud. Okay, what is most important for us is the chapter in the case studies which is called lessons learned, right? So about security, for example. I picked a few. I mean, we identified about 14 challenges. And there is a list, it is there, but I can't. I picked 4, the major 4 which we usually get asked. So security. This is interesting because, okay, so we know about security and privacy and so on, so I don't have to go into that. Some recommendations which came from our users, not from us. I mean, it's a crowdsourcing initiative. Everybody contributes and they write their stuff. Document your security requirements, select a suitable provider, and we have them. So we look at their requirements, we have a search function in our database, and for the experiments, we then recommend 1 or 2 resource providers. That's not what we do on the marketplace. The marketplace is really just kind of an online platform which we don't influence. We cannot influence. I don't know if there are the end users and there are the providers, hardware, software, expertise. So, okay, so here you see, select the suitable provider, and there are additional things which you can put in, which is encryption, VPN. You can use dedicated cloud server these days, and it's yours for the time you pay for. A one-node, 32-core typical cloud server is about $1,000 a month these days, right? So very affordable. A whole month, number crunching. You know, at home you might have 4 to 8 cores. Here you get 32 cores, and very soon you get 64, etc., and higher when you want to use containers. Containers currently are one-node stuff, but we have a big project together with Lawrence Livermore and Intel where we do develop multi-container containers which talk to each other, right? So you can do any kind of parallel stuff. Okay, so the comment is what is not widely accepted in the community. The clouds today are at least as secure as what you have in-house, because they have a big, $300,000 security officer often, and they take care of, they have a team, and they take care of security. I mean, to my best knowledge, Amazon AWS has never been hacked, while other big companies' data centers have been hacked regularly. So, I mean, obviously they have to put a lot of brain and money into security, which especially small, medium-sized enterprise cannot at all afford, right? Okay, so data transfer. It is about the last mile. I mean, that's the major issue. Still 50 gigabyte, I mean, and really depending on the last mile, they can be at your place in 1 hour or in 10 hours, right? So that's not a cloud issue, basically. It's more like your issue, and you could get a faster interconnect if you complain about that. So this is just about money, right? So, okay, recommendation is very nice new technology, just recently came on the market, vCollab, interactive. So you decide which byte you want. Yeah? So you click on, I need the coordinates of my, streamline of my fluid field. I need the velocity, and I need the temperature. Okay, immediately you reduce 50 gigabytes down to 50 megabytes, right? And this is whoosh, within seconds that is over at your place, right? Okay, use remote viz. So we have built-in remote visualization capabilities in our containers now. So you can just push a button and say remote viz. And then there is DCV from nice software in Italy in the container connected to the software. When we use OpenFOAM, we have ParaView sitting in the container and these kind of things. So yeah, if necessary still, and about 10 of our end users in the experiments, they shipped it to overnight via FedEx. And in the morning when they came to work, data was there, right? Very secure. So, okay, so that's, I mean, it sounds somewhat funny, but yeah, clouds can't solve your last mile problem with that one. Software licensing. So as you see, there is ANSYS now there. I can see that many companies, many ISVs say, ANSYS is doing that. Yeah? So now I have to do it as well, right? So this will have an impact. So recommendation is check your CAE software stack from the cloud. So, and you don't have to do it any longer. I mean, this was an early recommendation. Now you go in the marketplace. You go into the OpenFOAM store. And you see, OpenFOAM is sitting on Ohio Supercomputer Center, on Nefoscale, on AWS. Since about 2 weeks, it's sitting on Azure. And it's all in the container. So it is everything, wherever you go, it is few seconds, right? You will get, when you click on the product in the marketplace, you will get an email, welcome, Tom. Here is your access link, and here's your password. Tick, tick, tick. And then you are immediately in your container, in your OpenFOAM container in the cloud, right? So yes, ISVs should develop on-demand software licensing, which they do now. Yeah. So this is a summary slide, which is about 1 year old, and which is very nice to see what happened. Some ISVs, and I mentioned that in our panel, CD at Upco, Comsol, and others, they already have very nice cloud licensing schemes, and not usually made for cloud licensing in the first place, but to make their users doing their licensing more flexible within the in-house, within the company, and so on. So this is a nice one. I don't see that in 2 years anymore as an issue. Maybe even now. So cloud cost. There is a very nice paper, I hope it's nice, on our www.theubercloud.com/cost site about comparing cost things for workstations versus servers versus clouds versus hybrid. Yeah. So especially with hybrid, what is the best mix? In-house, external? This is the question. So recommendation. Okay, I mentioned it here, yeah. Automated, policy-driven monitoring, usage billing. So that's basically in part of the containers. So you can do monitoring and reporting about what you have consumed. And replacement and bursting are two different. Oh yeah, so that's another comment. So I would never ever recommend someone to replace an existing, nicely running internal server. Leave it up. Use it continuously for your solid, very important strategic work, and start softly, to burst out into the cloud, and then more and more, and you will learn about your break-even. So makes a lot of sense. So another challenge for many of the users already today is that the market is already overcrowded. I mean, only in our UberCloud community, there are 54 cloud providers all around the world, and over 100 ISVs in the meantime. We have 28 stores. There are almost 25 now, so in the order, sitting in the waiting queue. So I can't be so fast to get them all on the marketplace. So obviously, that's another trend we currently see, that on the provider side, there is huge interest to be there when the big trend on the user side ramps up, but that's what the users currently see. Yeah. So what are you doing as an engineer? So which is my best suited cloud provider, for example? That's a good question. And the only this I forgot to delete. So these are sponsors, partners, customers for now, and okay. So yeah, now to the marketplace. So that's what they see, and that's what a marketplace usually does. I mean, in any area. Yeah, it can be a shopping mall. Yeah, thank you very much. It could be a shopping mall. So the marketplace looks like that. And this is all about, the original title was, the idea was to start from where the panel ended, so from on-ramp, then over to how do I get to bigger HPC, which has been nicely answered by our two big guys, and then to the cloud, finally. So this is the first 10 providers. This is software. And so you click on it, you're on a store, etc. So I don't want to go that. So the final breakthrough for us was when 2 years ago, I mean, we are just sitting around the corner from the Docker guys, right? And Burak and some of their guys, one of their guys, they are close together. So they invited us to their very first workshop. And we found out that this is, at that time it was not really suitable, but we made it. So build, ship, run, any app, anywhere. And it really does what it promises, right? That's why, I mean, the whole Silicon Valley is crazy about Docker currently. It's a real, it's a hype, but it's a real thing. So let me just show you that one. Ready to execute packages of software. They are sitting on any kind of cloud server. So they just raise their arm. We want to have an Ansys container, right? The Ansys container, can you imagine? I mean, originally Docker was a microservice container. The Ansys container has Fluent, CFX, mechanical, LS Dyna. I heard LS Dyna several times. Nice scaling effect, yeah, for that one. And electromagnetics and something else. So this is about 40 gigabyte. So that's one container, right? So that's what you can do these days. We really drove it to the limit. Okay, so designed to deliver the tools that an engineer needs. ISV, open source, everything is you could come with your own application in-house. Finally, you could get rid of all the issues. You throw your in-house developed code into a container, and then you can hand it over to all users. And you can store it and do a next generation one and whatever. So ready to execute in an instant. No need to install software anymore. I mean, it took us from our 15 ANSYS took about 5 months to develop, to containerize. Now our 16, the next release, 2 weeks, right? So it's mostly a copy and paste and test and evaluate thing, right? So it's based on Linux containers, which we tried 2 years ago and failed miserably. Very clumsy, not very easy to use. And luckily then, in almost the same month, Docker showed up. And yes, so you know the other things. So it's like that, yeah. It is very nicely build, launch, control, run. So you can do it like that. So you build your own container, you put the application, the data, the tools in it, and then you launch it. The containers are sitting on a thin runtime layer, which is standard. So this is the great thing. It runs, as you see, on workstation, on cluster, and on cloud. So, you got it? No, you're very welcome. You can have the slides, by the way. Yes, so that's a longer list of the roadblocks you can tackle with the containers. Some of them disappear completely. Others are nicer to you, so to speak. Okay, and that's it. So I hope I was really making it.
We have time for a couple of quick questions. Yes?
Tony, yeah.
Was that a stretch over there?
Wonderful to see where you've gone 5 years ago when you and I were working on cloud, and the whole container idea is really interesting. Like
I mean, SGI accompanied us from the first day.
Yeah, and so I have a question. Like there is, like Altair has now put out their own appliance where they're actually delivering the hardware, software to the customer, and it's all you can eat, and it's like your cell phone, where you're just basically paying by the month. Do you have any comments on that other sort of track?
I mean, and this is I should have put them on the slide, because there are many of these efforts now going on, and we know from many more which are under the hood currently. So I already talked to Jim Scapa about this. He was not really sure if this is now a competition, but this is his very specific Altair offer, service. He can easily put it on the marketplace if he really wants wider visibility, if he really wants to reach, I mean, not only his 2,500 customers, but maybe the next 25,000, right? So it's complementary. Whoever big guy is sitting here, yeah, we are exactly complementing. I mean, I'm absolutely 100% sure, and we learned it 1 year ago from ANSYS. So when they were planning this enterprise thing, they said, we are taking care of the big guys, and not possible for the small ones. We are taking care of the other 95% of the market. Thank you.
Wolfgang, thank you very much.
Okay,
We do
I'm
very
here.
much appreciate it.
Yeah.
He'll be here the rest of the day.
Thank you.